Hello, in this video we're going to look at a unique wing type, namely the lift wing design that has several benefits for the eVTOL aircraft. The lift wing design has been devised by Dusan Stan and utilizes all the best elements of existing technologies to give it unparalleled high performance. It combines a curved wing with a tilting ducted fan such that even when the ducted fan is in the hover position, the fixed curved wing generates lift. On this channel, Electric Aviation, we aim to inspire aircraft enthusiasts to bring forward an era of efficient and more sustainable air travel. Subscribe for all our updates. To understand the importance of the lift wing design, we have to understand the aircraft design philosophy first. Among the aircraft designers, there are two schools of thought. One group likes to keep the elements that generate the lift force separate from the forward propulsion system. The key benefit this offers is added safety. That is, if the engine fails, then at least the lift generating elements, that is wings, can still gather lift force at the expense of potential energy of the aircraft, and that lift is enough to glide the aircraft to safety. The second group of aircraft designers look to create synergy between the wing and the propulsion system. They try to use the thrust of the aircraft not just for the forward push but also for the lift. This can give the aircraft more aerodynamic efficiency and better takeoff and landing performance. Examples of these are blown or excited flaps, channel wing, and distributed propulsion wings. Aircraft based on this philosophy have been designed in the past and have demonstrated remarkable performance characteristics that are unmatched even by modern aircraft. A case in point is the McDonnell Douglas YC-15, a heavy transporter that was able to land and take off from a semi-prepared airstrip of just 610 meters. Nonetheless, these aircraft did not prevail because the failure of the propulsion system also meant that the lift generating system on its own wasn't adequate enough for safety requirements. The course that the aviation industry has taken is to compromise on the aeropropulsive efficiency and high takeoff and landing performance for more safety. That is, lift and propulsion systems are kept separate, and the high efficiency aeropropulsive systems took a backseat in the late 1970s. Comet, the electric aviation age, and the battery's limited energy capacity necessitated looking into ways in which we can make the aircraft go the distance. Urban air mobility also required high takeoff and landing performance. Therefore, most of the designs that have made decent inroads in meeting the new age performance requirements have aeropropulsive efficiency at their heart. Electric propulsion also brought with it the use of electric motors, which were scalable without any loss in efficiency. Hence, it made it much easier for having distributed electric propulsion. And with that came redundancy, which also meant safety. Hence, the second school of thought that looked at generating lift from thrust-generating elements has now got a new lease of life, and this time also has safety on its side. And so we can again look at the synergy between lift and thrust, and the lift wing design is an ideal form of that. As mentioned before, the lift wing is a combination of a channel wing and a tilting ducted rotor. In the takeoff, landing, and hover phase, not only the tilted duct rotor generates lift, but also the lift wing that connects to the bottom portion of the duct. Dusan Stan has showcased different aircraft designs that incorporate the use of tilt wing through his company website Aliptera. These include a delivery drone, a two-passenger eVTOL aircraft, and a single-person prone pilot hover bike. It is mentioned on the Aliptera website that the lift wing takes the best of all technologies and is the most efficient design for VTOL aircraft because it creates more lift at low speeds and is able to fly at higher forward speeds without increasing drag. It provides 65% more lift than an open propeller and 20% more lift than a shrouded propeller. In this regard, it is better than a plain hover eVTOL, be it open rotor or a ducted rotor. By using the lift wing, we can also create aircrafts that are better than both tilt rotor and tilt wing types. It is interesting to note that Aliptera introduced this concept back in 2015, and this was earlier than many of the renowned eVTOL companies of today. The Lilium jet also uses almost a similar design, with only difference being that the fixed portion of the wing is straight rather than a curved channel. If lift wing design is used with not just one but coaxial rotor ducted fan, or two or more lift wing sections are used on either side of the aircraft, then redundancy can also be ensured. More details on this concept can be found on Elliptera's website and their YouTube channel. And with this, the video is concluded. If you learned something from it, then please do give it a thumbs up. Thank you for your attention.